Hello everyone. My name is Zhe Yang. I'm now working at Tongji University, Shanghai, China. I'm going to talk about the initial results from the Macau Sun satellite. And our focus is on the ionosphere irregularities and the scintillations at equatorial and the low latitudes. I would like to thank the contributors to this study. In this talk, I'm gonna first give a introduction on the equatorial plasma bubbles and the scintillations. Then I will talk about the radio occultation observations from the Macau Sun satellite and how we apply the observations to study the plasma bubbles. So our focus is especially focused on the reconstruction of the plasma bubbles. So over the South Atlantic region. So I will, present the initial results and give the conclusions. The Earth's ionosphere is a critical, part in the Sun and the Earth connection system. And the dynamic of the ionosphere is very, complex. It's associated with many, physical processes in the Sun and the Earth coupled system. And the plasma bubble I'm going to talk about is, a kind of irregular structures that generated at equatorial region and divide, at low latitude. The generation of the bubbles, are the results from the equatorial electrodynamics. At the equatorial region, we know the geomagnetic field is nearly parallel to the Earth's surface, and it plays, fundamental role in the generation of the bubbles. If you look at the, observation of the bubbles, it's like the, a sharp degree of the plasma density. Oh, sorry. And you can see the figure on the left hand is, the observation of the plasma bubbles. The bubbles are usually develop at night, and it's generally accepted that the bubbles are generated due to the, the relatively stability process at the bottom side of the F region, and there are two, conditions that help to, generate the instability process. One of the conditions is the rapid destruction of the E region after sunset. And another condition is the pre-reversal enhancement electric field. So they both, contribute to the stability. There are many driving sources of the plasma bubbles. And if you look at the flow chart here, the red color blocks are the parameters that play direct roles in the process leading to the bubble generation. I will not go into details, but I would like to mention that the pre-reversal, vertical drift of the ionosphere plays very important role in the generation of the bubbles. And the sources to drive the growth rate can be the magnetosphere disturbance or the disturbance from the lower atmosphere. Investigation of the plasma bubbles are very important. From the scientific aspect, we want to get know about the ionosphere dynamic surrounding the Earth. And another aspect is from the practical interest, because the bubble can cause, scintillation impacts on the radio signals, like for the global navigation satellite system signals. The bubble can cause the scintillation impacts, and they can cause the signal fading or even the position failures. So study on the bubbles are very important from both the scientific side and also the practical interest. The GNSS receiver, is one of the important, payloads on board the Macau scientific sunset satellite, and there's one, radio occultation receiver on board the satellite. And the radio occultation, I would like to mention that with GNSS is one of the powerful technique developed for vertical sounding of the Earth's atmosphere. And the McCall-Sun satellite carries one radio occultation receiver. And since the satellite launched on 21st May of this year, there are about 400 radio occultation profiles per day. And you may see the figure on the right hand. This is the data coverage from the McCall-Sun satellite about the radio occultation data. Yeah, you may see the data covers the low latitude region, and they provide very valuable information to study the Earth's atmosphere. As I mentioned earlier, the radio occultation technique is very powerful. And there's a specific the satellite mission that's specially designed to get the radio occultation data, like the Cosmic, the satellite mission launched by US. And this mission consists of 6 satellites. It's different from McCall satellite, and they have very different scientific objective. For Cosmic, it's specially designed to study the Earth's atmosphere. But for McCall, we know that this is on the geomagnetic field. But we look at the data. Okay, sorry. Oh, sorry. We look at the data from both the the mission, and we compare the Cosmic, the McCall-Sun satellite have very good local time data coverage. So I think they can be combined together to study the atmosphere at a low latitude. And if you look at the observations of the bubbles from both the 2 satellite missions, you can see the here list shows the figure that the bubble occurrence as a function of the local time and the magnetic latitude. So what you can see here is the McCall-Sun satellites show very local time dependence of the bubble occurrence. As I present that the bubble developed after sunset, and here you can see the McCall-Sun satellite. The observation from the McCall-Sun satellite shows the local time dependent of the bubbles. So I think this is very encouraging. And our study, especially focused on the South Atlantic anomaly region. So we know this region is intensified weakened of the Earth's magnetic field. And sorry, something didn't appear. Okay, and this region, the weakened magnetic field allows something happens in the Earth's atmosphere or magnetosphere and also the atmosphere. And they can cause the irregular structures like a plasma bubble. And the bubble can make troubles to the communication, with satellites, aircraft, and the space shuttles. We retrieve the data from the Cosmic because it has a long data period. You may see over the South Atlantic anomaly region, the bubble occurrences are quite often. So this is why we study, focus on this region. We made an attempt to do the reconstruction of the bubbles over this region. And first, we retrieve the scintillation profile data sets from both the satellite missions, and then we get the bubble observations in terms of their three-dimensional and the spatial variations. And then we do the construction by the empirical orthography function. And on the right hand, this is the reconstruction process. We are trying to get a series of basis function and to reconstruct the bubbles, the bubbles in terms of their three-dimensional and the spatial temporal variations. Sorry. And why we do the construction? Because we want to take advantage of it to study the atmosphere science, and also can be used in the atmosphere space weather study, like to help forecast for the satellite navigation. Okay, so now let's look at some of the results from the reconstruction. And we selected the first two components from the EOF analysis because it's already accounts for almost nearly 98% of the data of the variance of the data set. So on the right hand, you can see the first EOF basis function, and we see the results looks very good because it shows a very variation with the longitude and the latitude, and also varies with the altitude. We do a calibration or validation by the observational data set, and on the left hand you can see they have very good linear correlation. So I think the reconstruction is working. Yeah. Okay, this is the results of the reconstruction that shows the plasma bubble occurrence, bubble morphology in two dimensions, like in the you can cause the data for Macau-Sun satellite now covers were collected during the we use the data that collected during the June solstice season. So this will show the clear seasonal pattern of the bubbles. And here's the dynamics. I think that shows quite amazing that the construction results looks shows the seasonal the three-dimensional variations of the bubbles. So over the South Atlantic region. Okay, I'll make the conclusion now. So this study presents the initial scientific results about the bubble observation retrieved from the Macau-Sun satellite, and we mainly focus on the South Atlantic anomaly region, and the results are encouraging and suggest that the satellite observations indicate a typical local time, latitude, and altitude dependence of the bubble occurrence. And I think Macau satellite observations can be potentially applied as addition to our constellations, or combined with other data, other satellite missions, contribute to to study the bubbles or even other irregular structure in the atmosphere, or some atmosphere anomalies at low latitude with high local time and the vertical sounding resolutions. Okay, that's the end, and thank you.